devices on Profibus, for example. First step, select the selection of the communication, of the protocol. Here, in Schneider catalog, the possibility to go to have the connectivity to Profibus DP is the PRN, the Profibus Remote Master. It's a very powerful name for a gateway, but it's the gateway from Ethernet to Profibus DP. And this gateway, this PRN, is managed, of course, with a DTM. I select, give the name to have automatically the good variables. In my frame application, I can see the Profibus Remote Master. If I click on Add, I have the list of all DTM installed on my computer and compatible with Profibus DP communication. I select the first one, change the name or not, and of course, if I double click in my software on the DTM, I have not the Schneider interface, but the user interface and the good functionality and parameters and diagnostic tool developed not by us, but by the manufacturer of the devices. And this manufacturer is Rotork. But if you store the application, the parameter of this device will be stored in the same file with the configuration of my PLC. You have questions?
Okay, if not, good afternoon. My name is Mike Federal. I'm from Rotork. This is the second part of Rotork here. It's a bit of a turnaround. So this is a good example of the interoperability. So we see the Rotork DTM running in the Schneider system, and here we have the same DTM running this time in the M&M FTT container. So I think before Pactware was mentioned as one of the free containers, and there's one from M&M Software in Germany called FTT container, and that one is the one that we're running. You can see the DTM looks, exactly the same, and it will do all the same. So it's a good example of how the same DTM integrates into PLC vendors' systems as well as these ones, proprietary systems, all looks the same. So here we have it running. Now it could be running as part of a GCS PLC system. You can also run it just on a laptop or a PC computer. And what I've got here is this interface to give a Profibus connection, and I'm using this Brad communications device. So again, not Rotork, it's another interoperability thing. We're just using a third-party device, and that gives the Profibus interface functionality to the laptop computer. There are ones from Softing and D&H and so now that I've got a Profibus connection, I have two actuators here. So Rotork make actuators, that's what I do. And this one, a rotary actuator, typically we use on medium to large valves. And this is the percentage opening that you can see on the display. So this is a relatively new product, building on previous generations, which look similar, but this is a more advanced display. And we'll sort of have a look at how the DTM can be used to configure operations, and just make that a little bit easier. This one is called CVA, which stands for Continuously Variable Actuator. And this one would typically be used in process applications. So you may find this feeding, say, feed gas or oxygen into a furnace, for example, and it would continually move up and down to regulate the flow, to provide the right air-fuel mixture or the right temperature, etc., or the right flow of chemicals. So this can continually move all the time. And this one would tend to be used more for open and close duty, although it can be positioned as well. So typically, when you're commissioning a plant, you may find that the PLC, the DCS system, isn't installed yet, but yet parts in the field, such such as the actuators and valves are there, and they may wish to, say, close it, open it, run it to 25%, etc., in order to commission other parts of the furnace, for example. So while the sort of hardware components are being installed and finished off and tested. So before you have your full control system in operation, you could operate it using local controls. You could even handle one of it if you want, but a nice neat way of both testing the Profibus communication and operating it and configuring it would be to use the DTM for this kind of setup. So this could just be on a PC or a laptop here. It's nice and easy to do, quite compact. And so here I have the DTM. This is the main page for this one. So it looks very similar to this one. And I just have some, so this is online now, this is the sort of live data. I have some configuration settings here, which can be used to match the actuator to the type of valve, some information, tag names, analog information here. Now, a useful screen is this one here. So this is observing just what's happening at the moment. If you have some alarms, for example, you can read what they are here. I've made the resolution quite low to make it big, but it means I have to just scroll around a little bit. But here we see, is the valve obstructed, jammed, is there control contention, is there a partial stroke error, is the thermostat tripped, there's a monitor relay monitoring condition, is there a low battery. So all of those are no, so it's a happy actuator. So that's fine if it's here, and we just look at that, we can see there's no errors. But if it's at the top of a flare stack and it's very cold outside today, you possibly don't want to go around your plant checking all of these things. So it's a nice way of checking for status bits here. Also, in some PLC systems, I found the vendor licenses the number of tags or something. So you don't always get that much information available back. They may be monitoring whether it's open, closed, has a fault, but it might not go into all the detail for all the items that are available on this device because they don't want to pay, you know, if you have 100 of these and 20 it's monitoring for each actuator, you have a lot of tags, they may not wish to do that. So you can get a lot of information from this screen. And you can see if I change it into local, for example, a few things changed. I'll change it back. So that was local selected went to no, and remote selected went to yes. So it's just a quick sort of status check, very nice and easy. We can also go to the control page. So again, I have a graph which is showing a position, which will start coming along here. This will also show torque data, and I can move this open and closed. But you can see it responds nice and quickly. I can also go to a certain position, so the commissioning device and say, okay, we want this at 55%. That can send the actuator. It should reach about 55%. May overrun very slightly depending on the settings. Okay, 54.9 is just there. But we can also use this to adjust some of the other settings to match this deadband and hysteresis settings which are set in order to match the actuator to the valve so that you have accurate positioning. So if you have a very heavy valve with a lot of momentum, you need to cut the motor before it reaches its desired position. So you can use this to do that rather than have to be out in the field or to use other tools which don't have nice graphical interface. So that's excellent commissioning, and it's very similar for CBA here. I can open the control page. So sending it open, closed. If I go to this one, so here we don't see any torque actually connected to it, but if there was a valve connected to it, for something like a butterfly valve, you might see a higher torque as it seals, and then a high torque as it unseals, and a lower torque as it opens the rest of its travel. And you'd be able to see that fed back here when the position reaches zero, the torque goes and jump up. Now, this is a good diagnostic tool because over the life of the plant, you may start to see the seals deteriorating and also some sediment around the valve may stop it moving as smoothly. And you can look at the torque as you move it, and that will kind of give you some information about the condition of your valve, possibly the actuator as well. So it's useful in the commissioning stage, but it's also useful in the asset management up to maintenance phases because it gives you that information. And these actuators will also store the torque values seen at different percentage of their travel for open and closed. So rather than trying to have this open all the time, you can specifically go and monitor it and look at the full stroke if you want. But it may be that the process that's being run doesn't often demand a full open or full closed, and many sites run 24 hours a day, so you can't just do that. However, over its history, as it has moved open and closed, it will store torque at those particular points, and you can then read that back through an ATM, and that will show you sort of a history. So you can compare that to when it was new, and that will give you an idea of when your valve may need maintenance. So the idea is that you can schedule that for a time in your process where it's easy to pause production, say in a month's time, rather than waiting for 2 months and then suddenly it becomes jammed, and at which point you have to stop your process.